Hello everybody, and welcome to another lecture of algebra for intermediate algebra. And today we're going to be looking at ratios some more. When I say ratios some more, we've already talked about rational expressions and rational equations. And the root of the word rational is ratio. So in 7.6 we're going to be looking at ratios and proportions and some problem solving. Now today's lecture is going to be in two parts because we're going to first of all address ratios, proportions, and some problem solving, and then we will finish up with part 2 of the lecture, or part B of the lecture, when we deal with more advanced problem solving. But first of all, let's define what ratio means. All right, the word ratio has its basis in the word rate, and we all know how to determine rates. Okay, we can determine the rate of the price per item by dividing the total price that we pay for a certain number of items. We can figure out our miles per gallon by dividing the total number of miles that we traveled over the number of gallons that we filled up our tank with. So we deal with rates all over the place. But the ratio of A to B, when we're talking A to B, we're talking about the ratio of two values. It can be written in this way, A colon B, or A to B in words, or as the fraction A over B. Ratio is quite simply the quotient of two numbers. All right, when we talk about ratios, units are going to be extremely important. All right, the reason that I mean units are going to be extremely important is whenever you figure out your miles per gallon, all right, you're not trying to calculate price per item. You're trying to figure out miles per gallon. And whenever you figure out how fast you've traveled to get from one point to another, you're figuring out miles per hour. So we have to keep in mind that units are extremely important. For instance, if you buy $52 of gasoline, now that doesn't seem like much anymore in today's economy, but if you were to buy $52 of gasoline and you were able to purchase 13 gallons, to find the price per gallon means that we would divide 52 over 13. But what's important is that we keep in mind our units of dollars over our units of gallons. When we do that, we then calculate it and do our division. We end up with $4 per gallon. Per is simply a word meaning ratio. It really does. It just simply means ratio. So every time we deal with a rate, we're going to be using the word per when we're dealing with a rate. Now, not every ratio has units associated with it, but this right here is called a rate. And the word per is operative for rate. All right. So now let's recall fraction simplification. Hopefully you recall fraction simplification. When we looked at simplifying fractions, we had like 12/14 and we simplified it to 6/7. Remember, when we took 12/14, we found out that both the numerator and the denominator divided by 2 by the fundamental principle of fractions, and we ended up with 6/7. Now what we have here is a proportion because we have 12 over 14 equals 6 over 7. What that means is the exact same thing is done to the numerator as it is to the denominator. We can create any kind of proportion as long as we do the same operation to the numerator as we do to the denominator. So a proportion is defined as two equal ratios. Here's an aside note. Is 5/8 equal 10/24 a proportion? Well, if we look, when we multiply 5 over 8, if I want to get to 10, then I would multiply the numerator by 2, right? And if I multiplied the denominator by 2 as well, we would end up with 10/16, not 10/24. So in answer to this question, is it a proportion? No, it is not a proportion. The reason it's not a proportion is the same operation of multiplication or division is not done to both the numerator and the denominator. So, let's also recall how we cleared fractions to solve rational equations. Ladies and gentlemen, we have this A over B equals C over D. Now, if we clear fractions the way that we learned in the previous sections, then we would look at the LCM as BD. What do? We multiply both sides of this by BD. And on the left, the B's cancel, so we end up with AD. And on the right, the D's cancel, so we end up with BC. Now notice, though, that since we have a single ratio in each side, we can use a little bit of something different. What is that something different that we can use? We can use what's called cross products. Now let's explore cross products. We have this ratio, or this proportion of A over B equals C over D. A over B equals C over D. By using cross products, we end up with AD equals, and then we cross the B and the C, equals BC. Now, isn't that the exact same thing we had right over here? It is, isn't it? So by clearing the fractions with a proportion, we end up with the same thing we get when we use a cross product. So, we can use cross products to solve proportions. Now I'm going to give you a warning. Warning. To use cross products, we must have a proportion. In other words, one ratio equaling another. Let's look at this example here, the example that I started right down here. We're going to move on to the next page because we need a little bit of room for this. Do we have a single ratio on the left? Yes, we do. We have a single ratio right over here because there's just one single fraction bar. We have a single ratio over here as well. So what are we going to do? We're going to use cross products. 3 times x plus 1 equals 5 times x plus 2. We've successfully cross-multiplied the two of these. Now, after we've done that, let's take a look at what we have here. What we have here is an equation that doesn't have any fractions in it. Sounds kind of like that first step when we talked about solving rational equations and then solving rational equations for designated variables. That the first step we always do is clear fractions. Well, right here, ladies and gentlemen, we have no fractions. And then we clear parentheses, if you'll recall, from the steps. So let's take a look at this here. So cross products is just another way that we clear fractions. It's really the same thing that we've been doing. It's just a shortcut. So once we do that, then of course we isolate our variable term, as we've done so many times in the past in solving so many of these, and we get 2x equals negative 7, so x equals negative 7 halves. Now, it's very easy to check this. We have negative 7 halves plus 1 over negative 7 halves plus 2. Negative 7 halves plus 1 is the same as negative 7 halves plus 2 halves, and negative 7 halves plus 4 halves in our denominator. So we end up with negative 5 halves over Yes. All right. Negative 5 halves over negative 3 halves. The 2's cancel because whenever we divide fractions, if you'll remember, we multiply by the reciprocal. The 2's cancel, the negatives cancel, and we end up with 5/3, which is exactly what we have right here. So this works, therefore, there is our answer. So we can use this process to solve so many types of proportions, yes. Oops. Yes, that's where we needed to go next. I apologize. Let's look at a problem-solving application. Now, this comes from your text. If a 170-pound person weighs approximately 65 pounds on Mars, how much does a 9,000-pound satellite weigh? All right. To set a proportion up, we have to declare what we are comparing. Okay, what are we comparing? We're comparing two items. What are we comparing? We're comparing the weight on Mars to the weight on Earth. So we've got weight on Earth compared to the weight on Mars. So a 170-pound person would weigh 65 pounds on Mars. Pounds over pounds, the pounds cancel. All right, good. But this is a proportion, ladies and gentlemen. It's a proportion. How much does a 9,000-pound satellite weigh? So 9,000 pounds. We've got this 9,000-pound satellite, and we're fixing to launch it to Mars. Right now it weighs 9,000 pounds and we're on Earth. So where would the 9,000 go in the numerator or the denominator of the other side? Well, we have to maintain consistency with our ratio all the way across here. So the 9,000 would go in the numerator and our unknown would go down here. Now the question is, do we have a ratio? Yes, we certainly do have a ratio here. So we're going to cross multiply, or not a ratio, yes, we have a ratio here. We have a ratio here. A ratio equals a ratio is a proportion. So we can use cross products. So what do we have here now? 170x equals 9,000 times 65, which is going to give us 585,000. Now we would divide. So 585,000 divided by 170 gives us 3,441.176. And typically we would round these to whatever the instructions tell us to, and I apologize that I didn't give you the instructions on how to round that, but we would go ahead and round that to 3,441